Hey, Margaret.
Hi, Mr. Walker.
How's it going?
Good. Are you getting any reverberation? Can you hear yourself talking while I'm talking, by chance?
Sounds pretty good to me.
Okay, because, got something weird going on. I think I probably told you this before, but I actually have two screens, so you can see I've got a TV screen here, and then I got my regular computer screen, so sometimes the sound actually comes through the TV instead of through the computer, and that is not good. I gotta fix it. There we go.
So okay. let me know if you hear reverb burp. That was
right.
me.
Yeah. Right.
Trying to be helpful like always.
Indeed. How was your weekend?
It was good. Yeah, good. All right, I got to get the email I sent you guys because it's got all the things lined up. Today's videos. Here we go.
Yeah, I saw Robin's doing Oobleck. I found a couple of, I think that was on my YouTube suggestions page. That stuff's really cool.
Yeah. Joel, Olivia, Sanvit, Maya, Robin. Alright, so Joel is this guy. Stop. Then we got Olivia. Talking to myself for a little while here. Well, okay. Then we got Sanvit. Then we got Maya. Then we got Robin. Chandler. Ooh, Chandler. Hey, Joel.
Hey, Mr. Walker, how are you doing?
I'm good. How you doing?
Pretty tired.
Yeah, you and Willie took the Chem AP today, huh?
Yes, sir.
Yeah, our kid said it was a little on the brutal side.
Yeah, me and William didn't think it was too bad, which I hope is a good sign.
That's a good sign.
It could work against us, but...
Yeah. They thought the multiple choice was what they expected, and they thought the problem section had a few tricky ones on it. That's what I heard from them.
Yeah.
I'd say the problems ones was maybe the harder part, but for the most part, I think our teacher really prepared us for it.
Yeah.
All right, good. That's great. You guys do 2 years of chem, right? You do an intro chem, and then the second year is your advanced class. Is that right?
No. Well.
Everyone takes chemistry sophomore year, and then AP chemistry is offered as a junior or senior class.
All right, that's what I meant. Yeah.
Yeah.
Only 1 year is required.
Okay.
I think this is all your fault.
Yeah. Hey, Sanvit.
So how was my new video? Did it look any better?
Yeah. Max, what are you doing at home, you punk?
No excuse. No excuse.
I was going to ask if you aren't feeling well, but I assume you're feeling fine.
I'm feeling pretty fine.
Yeah. Did you miss school today?
Yeah.
Okay.
It's just tennis.
Nice.
Oh, here, I have something that I did last week that you guys will appreciate.
I like the column architecture in his house.
Right?
That looks like a very old Southern kind of home.
I got angry while playing tennis.
Oh. Uh-oh.
Wrecked.
It was, the
Did
thing
you-
was,
did
it
you
was
get angry 'cause you
initially
took
an
a scam?
accident. I didn't even throw it that hard, it broke. But then I was just kind of like, it's broken, so I'm going to really break it.
Wow.
Really break it.
Wait, so you struck it once and then you struck it again?
Well, what happened, yeah, so I got upset and I threw it. And I do that a lot. And something about this time was special and it broke. So then I just kind of kept doing it.
Why is this the last week of class?
Let's tighten that camera angle up on you a little bit.
Sure.
Well,
Why not?
I can share with you guys my my favorite project of the week. You look over there. You can see on my canvas wall there's a foam plate attached to a piece of cardboard, and then on it is actually this is actually a headphone cable, and so I can plug this into my computer, and that foam plate is a speaker
Wow.
made out of like just a magnet and some wire, and it
That's
works
really
pretty
cool.
well.
That's really cool.
We did that in our engineering class, and we
Yeah.
ordered these special like neodymium magnets, and they're so
Yes.
strong.
Right.
And so
those.
so there's like these like little kind of discs, and it quickly turned really bad because they were sticking to everything that was metal in the classroom, and so like now you
And
kind of go in the
phones.
engineering class, and there's just like neodymium magnets like stuck under his desk and like stuck everywhere, and like our teacher cut his arm because like a neodymium magnet like kind of sliced him up as it came up his arm. Those things are like dangerous, but it was cool.
Wow.
Yeah, and you can't get them anywhere near your computers or your phones, or they'll screw them
Yeah.
up. It's scary.
Hey, Olivia.
Hi.
Welcome to class. Max, I haven't had a chance to check out your video yet. I don't know if we'll get to it in class or not, but if not, we'll get to it Thursday. Sounds like you were a little frustrated. You're muted, Max.
I was literally yelling at my computer this morning. I could not figure out iMovie.
You should have smashed your tennis racket.
Yeah, I did that. I made it worse.
What problem did you have with iMovie?
It was weird. I actually think there was just something wrong with like my computer and iMovie because I quit out of it and then it started working. It was like I was trying to like superimpose some audio over like PowerPoint slides and it was just not cooperating.
So, okay, I see.
It wouldn't let me move the what's it called, like the audio to the part of the movie. It let me put it in the movie, but it would only go right in the beginning, and it wouldn't let me move it, and I just could not figure it out, and I just quit out of it, and it worked.
Huh.
Yeah, I don't know.
Hey, Maurice. Hey, Chandler.
Hey.
How you guys doing?
Good.
Good. All right, 1, 2. Oh, Maya. All right, so right now we're waiting on Maya and Robin, and we're officially not started with class time yet anyway, so we're good to go.
So who had the chemistry or enviro the exams this morning?
How many people took the Chem AP this morning? That was Willie and Joel did. Anybody else take the Chem AP? Nope.
Took that one last year.
Yeah,
Yeah.
Max took it. Chandler, did you take it?
No, but I realized I gave you the wrong date for one of the APs I'm taking. I actually have to miss class on Thursday.
Chandler!
Chandler, shame on. Oh yeah, I do too actually.
What are you doing, Chandler?
Physics 2 is during that time.
Chandler, you're a bad kid. You know, I'm kidding, I guess, right?
Harvard boy.
You can't miss our last class. Chandler, did someone else say they were also missing it?
Maurice.
Yeah.
Oh, Maurice, you guys both are going to miss it. That's a bummer.
You're gonna miss the guessing how tall people are game.
I know, right? Hey, Robin, welcome to class.
Hello, Mr. Walker.
Are you still in Israel?
Yep, yes.
How's the fashion shoot going?
It's all right.
Yeah. Good. So, Chandler and Maurice, you guys are taking Physics 2 on Thursday. Do you also take the Physics C on Monday?
No, we have bio on Monday.
Yeah.
Oh, Bio Monday. Gotcha.
You take Physics 1 the day before.
How come your school offers Physics 2 but not Physics C? Is it is it just because they do, or is there a reason?
So I don't know. We just tried the new system this year. I think we do Physics 1 and 2 in the same year. I'm not sure if they're usually split up, but we don't offer Physics C, and we don't offer Physics B anymore.
Well, Physics B's gone now.
Oh yeah, is it? Yeah, okay, yeah. So.
Hey, Maya.
Hi.
How's it going?
Fine.
Good. Let's see. I don't know which of these videos will take the longest to load up, but Robin's took me a long time, but then I shared it. I think I shared it through Google Drive, so maybe it won't take that long to load up. You might want to try to load Robin's up. I think everybody else's is URLs from YouTube that are pretty quick loading. And I think our first one we're going to start with today is Joel's, which was the first one on my email. So could you guys pull up Joel's video and then give me a sense, thumbs up when you've got it going? Maya, before we do that, let's see. Ms. Zobe sent you the video for class, but it only came at some point today. So for the last class?
Oh, there it is.
Yeah, so at some point watch that and give me a yell back that you've done it. Max,
Okay.
you owe me like a couple classes you're going to show me, right? You're going to watch. Max.
I got to do the Sam Keen one and maybe like one or two others. I'm actually not sure.
All right, Samvith, your thumb is telling me you're good. You're good to go. You're sideways. All right. We're thumbs up if you are ready for ferric thiocyanate with a guy with guns showing. All right, so we're gonna watch Joel's video, and sorry, I was looking down and I didn't pay attention to the thumbs up. Can I see the thumbs up again? We all ready? Yes. Okay, so why don't we do the 3, 2, 1 countdown? We'll watch Joel for 2 minutes and 48 seconds, and then we'll get some live questions for Joel. Okay, Joel in 3, 2, 1, go.
experiment requires the
Uh-oh.
production of highly toxic.
Sorry, as soon as that happened, we go to another video of mine, so I got to stop that. Okay, great. Luckily, we have Joel present, and we can ask Joel questions if we want, or comments for Joel. Anybody? Margaret?
Not terribly relevant to the actual reaction, but I did notice this, the thing that you were using, like it looked like it had 3 different wells in it. I was wondering what if that has like a name. I've never seen that kind of implement before, and what it was made of, just out of curiosity.
Yeah, it was just like a ceramic little dish. I've never seen them before either. It was the first time I used it, but because it has it's a ceramic dish with like a white glaze over it, it really worked well for the standing out the color of it instead of having to hold it against a whiteboard or whatever. So yeah, it was the first time for me to use it too.
Have other folks seen this lab? This is usually, or a demo, it's usually one done in your intro chemistry class. Have people seen it before? I just want to get a sense. Oh, you hadn't seen it? Okay. Yeah, it's a good one to stress. Another thing you can do is add a phosphate compound that binds up to the iron ions and pulls them out of solution. So, Joel, what would happen if you added that? I think it's like sodium hydrogen phosphate, which ends up binding up to the iron 3. What would happen in that case?
Yeah, then it would shift back to the left and making it more yellow in color.
Yeah. And Joel, do you have a sense of what makes it yellow in color in the first place?
Yes, it's the iron ions.
Yep.
And then the complex ions that are formed make the red color.
Yeah, good. Joel, have you or anyone else done any spectrophotometry or done a Beer's Law plot in your advanced chemistry class?
I think we tried to do a lab, but it didn't really work too well.
But there actually is a ton of that on the AP Chem test, so we kind of wish we did do that.
Yeah.
That was the one thing that we really had no idea what was going on.
Anything with any colored solution, you can send light through it, and the more concentrated it is in that colored solution, the more the light gets absorbed as it passes through. So you can make a basically what's called a standard curve. It's called a Beer's Law plot that shows concentration versus absorbance. And then you can run the experiment under lots of different conditions, and you'll always know what the concentration of the colored ion is. So you can study that equilibrium pretty well using that device. It's called a spectrophotometer. So just wanted to see what you guys... And yeah, Margaret?
Does this reaction have any industrial purposes?
No, I didn't see any. The only... all the related videos on YouTube are making fake blood because of the dark red color. That was really all I saw.
Yeah, it's definitely very red. All right, good. Any other questions for Joel? Yeah, Robin, thanks.
So I don't know whether this is really an important part of the chemical reaction, but what were the temperatures of the places where you put the test tubes in? So what was the temperature of the water, sort of hot and cold?
So I didn't actually measure the temperature of the water. The water got up to boiling, and then I turned it down a little bit just because the hot plate was really hot. But it was near boiling, and then the water was pretty much ice cold. So it was more just to show that, I wasn't necessarily showing the quantity of the temperature. It was just that if you add heat, it shifts to the left, and if you make it colder, it's going to shift more to the right. So that was more the demonstration.
All right. Any other questions for Joel? All right, let's thank Joel again then. Let's see. Can you guys pull up Olivia's, which was second on my email list? It's another it's a URL from the internet. So when you pull it up, it'll show zinc plus 2HCl. And so if I could get thumbs up for when people have that ready to go, I'm good to go. Maya, Max. Samvith, is that a thumb up or thumb to you? It's a thumb up. All right. Dallas, Fort Worth, you guys good? Fort Worth and Olivia, you good? Olivia? All right. So let's do a 3, 2, 1 countdown for Olivia's video. 3, 2, 1, go. All right, let's see. I gotta escape out of here. My computer's trying to play everything on the internet now. Questions for Olivia about that one? Yeah, Willie.
Okay, this is more of a funny story, but so the experiment at the end where you make the bubbles, we actually did that by bubbling methane gas through bubbles and then putting it on our hand and lighting them on fire. And we our chemistry teacher has a really funny sense of humor, and so he got like a group picture of our class because there's only 6 of us in AP Chem, and so there's a picture of us like all standing there, and then in the background there's like a methane bubble on fire, and he like sent it to the administration to see if they would notice, and it was a funny story.
That was odd that you said your chemistry teacher had a sense of humor because usually that doesn't happen.
There were actually, when I was doing the experiment, there were like a bunch of kids in the room, like studying for some test or something. And so when that noise was actually really loud. It didn't seem that loud, but they all like screamed and turned around. It was funny. It was funny when it happened.
Samvit.
Was this like this reaction was quite exothermic, but I mean, was all the energy just converted like sound energy? Because I don't know, this just kind of like conflicts with my whole understanding of like sound energy as a result of vibrating waves or whatever. Something like that. Where did the sound energy come from?
From my understanding, that sound just comes from the hydrogen reacting with oxygen in the air, but I mean, I don't know if that's correct, or I don't know if that's the best explanation.
Anyone else want to hypothesize here? It's a good question. Willie?
So, like, when you burn the hydrogen atoms with oxygen, are the electrons getting excited, and then as they resettle into their new state in water, don't they release energy? Some of this energy is as light, and some of it's as sound. Is that closer, or do you get that?
Yeah, I want to see what other people think. You guys, anybody else want to chat that one up? Throw in some thoughts?
Yeah, so I guess Chandler and I have a thought. Essentially, like you have this reaction going on, this combustion reaction. So you compress the air nearby, and that compression, sound is a compression wave. Thus, you create the sound through the expansion of the air.
Yeah, I like that explanation a lot. We really have a mini explosion going on here. That's what happens in an engine when you guys are driving vehicles. Inside your piston, there's a mini explosion. So this is a rapid expansion caused by the exothermic reaction, and it's so rapid that it actually does create those sound waves that you were talking about, some of it, as it shocks the air as it leaves that rapid expansion during any explosion. So yeah, that's exactly what's going on. Good. Any other thoughts or questions about that? Let's see, it was Willie that gave us the description of hydrogen earlier about it burning with such a light, like almost invisible flame. Is that right, Willie? Yeah, so sometimes you don't even see that flame that she's talking about as much as you hear it coming out. And I was telling Olivia, when I first started teaching chemistry, this was back right out of college when I was teaching at a boarding school, I was trying things I was seeing in books, and one of the things I'd do is I'd put zinc in a Coke bottle and throw the acid in, and I had this long tube coming out that I'd blow bubbles with, and my class loved catching the bubbles on fire, but there was an accidental reaction that always happened, and that was after the bubbles would catch fire, I wouldn't realize it, but some of the flame would actually start working its way down the hose. And this takes a while to happen, so we'd be doing something else in class, and unbeknown to me, this flame was working its way down and somehow bringing in some oxygen with it, and it would form just a perfect ratio and would just go boom and shoot the cork out of the Coke can and scare the heck out of me, and the kids always loved it, so we'd do it again and again and again, and you could never predict when it was going to blow, and it was just really, really cool. So hydrogen does some crazy things like that when it gets that perfect ratio. It's a really fun reaction that always scared me. Margaret?
So if the sound comes from just the explosion sort of manipulating the air, does that mean that it's possible for the sound to be at different frequencies, or is it always the same kind of popping sound?
Yeah, I have a thought about that, but I want to see if anyone else has a reaction or thought about it. Yeah, Willie.
I'm 0 for 1, so I don't know if I should guess, but wouldn't it depend on the volume of gas that you're burning? Like, the more you're burning, the more air would displace, thus having a lower frequency?
Yeah, I think so, too. I had another thought, which is maybe the size of the test tube you're using, the container or anything like that. So I think there's so many variables that would be fun to, play with. I don't know if you guys watched, but Olivia filled that test tube with looked like to me about 4/5 or 5/6 maybe worth of hydrogen. And then when she picked it up, the rest of the water ran out, and so air shot in there. So she actually had a mixture of hydrogen and a little bit of oxygen and nitrogen. You can try to light pure hydrogen, and pure hydrogen won't do much. It has to mix with the air, I guess, obviously, to burn. So you could actually go into a room of pure hydrogen, and you wouldn't be able to light a match, and it wouldn't even be dangerous to do that as long as there was no oxygen in there. And a super crazy thing to do is to make a hydrogen balloon and then fill it, actually bring it to an oxygen tank and mix in another half part of oxygen, because then you've got a perfect hydrogen-oxygen ratio. That balloon will wake up people across your campus when you do it. It is crazy loud. So that's another one that I've learned over the years, to light from a distance with a candle on a meter stick and be ready for a loud pop. But it's definitely fun. Any other questions or comments for Olivia? All right, let's give it up for Olivia one more time. And we're going to roll to Sumvith's magnesium and oxygen reaction. So it's called combustion of Mg in air. And if we could get some thumbs up once we got that loaded up. Max is good. Robin's good. All right, Sumvith, you ready for your own? Yep, everybody's good. All right, so Sumvith's combustion of magnesium in air in 3, 2, 1. All right. So Willie's got a question.
So is the reaction exothermic or endothermic? Because it looks like it took a lot of energy to get going, but once it was going, it released a lot of energy. So how does it balance out?
It's an exothermic reaction ultimately with a high activation energy. Because you're forming a bond is an exothermic process, but because magnesium is not as reactive as sodium, you needed to invest a lot of energy to begin with. That's why we had a blowtorch thing. And basically from my previous research on magnesium, I learned that if you want magnesium to combust like that, you need to send it to a temperature of like almost 500 degrees Celsius. So basically that explains why the blowtorch was used, to get it heated quickly so that you didn't have to spend 5 minutes letting a Bic lighter just passively heat the thing. But yeah, it's an exothermic process.
Other questions for Sambit? Sambit, I've never heard of Periclase, so that's the name for the magnesium oxide product?
Yeah, magnesium oxide. Periclase is actually one of the ways magnesium was discovered. I learned that in my research. I think it was like the English Humphrey guy Humphrey Davy, who came up with that. If I remember that research correctly. And basically, Periclase is found in the most common minerals, in some of the most common minerals on Earth, which is basically the primary source of magnesium from within the crust.
All right, Margaret?
It looks like your reaction predicted that magnesium hydroxide was formed, and I was looking at this picture of somebody holding the tongs and the water solution. I was wondering if that's just a reflection, or if the magnesium hydroxide is a precipitate that you can actually see in the beaker, if you observe that.
If you just referring back to the video, remember that I mentioned in one of the footnotes to the second reaction that the activation energy for that reaction will be higher, because I realized that in order for this fire to keep going, the magnesium needs a certain energy quantity going, because otherwise it'll just fizzle out. Just going back to this whole thing between magnesium versus sodium, as magnesium is less reactive but still quite reactive. And what you're actually seeing on the tongs, to answer the other part of your question, is actually is most likely magnesium oxide formed. It is not the tongs burning. It is not the tongs melting simply because the magnesium sample was too hot. And then just off on a tangent on that, it reminds me that in constructing this demonstration with my chemistry teacher, we used a pure strip of magnesium. But had we used powdered magnesium, surface area would have increased exponentially, and as a result, we would have seen a much brighter image.
Yeah, I just wanted to clarify the question. I was just, there is no magnesium hydroxide forming in the beaker? Is that what you're saying, that reaction doesn't actually happen?
Unfortunately, that reaction does not happen.
Okay, gotcha.
Joel?
Yes, I was wondering if, because it's so bright, did you have to wear goggles at all?
That day I wore eyewear and basically stood to the corner of the fume hood with my camera in sight of the reaction. The light is borderline blinding, and in doing research prior to this, the website I read the experiment from and getting ideas for this suggested you wear welding grade eyewear if you're going to look into this thing. That partly explains. I mean, it only the dark room only goes to amplify the effect of that reaction. It's just even if something as small as maybe a centimeter square of magnesium can light up pretty much an entire part of a room from pure black.
Maurice?
Yeah, so this actually isn't really related to your video explicitly, but how much does magnesium cost?
How much does magnesium cost? I don't know.
Yeah. I'm thinking about making a purchase, so.
Maurice,
okay.
I think you can get it. I think you can get it fairly cheaply. I would be shocked if it's very expensive at all.
For elemental magnesium.
Yeah, we buy it by the roll, and it's very thin, but you can buy that stuff. I would think you could probably buy a roll for $20. I would think.
Awesome. Yeah, I think I might get some.
Yeah, every year I don't teach the intro chemistry class every year, but whenever I do, I insist on lighting it for my class. But I always say this, I'll light it with a candle because it will light with a candle if you're patient. I'll say, when I light this, I want you guys to look at me, and I'll hold my arm way out, and I say, don't look at don't look at the burning magnesium, just look at me. And every year, when I'm done with it, there's this kid going, because it's so bright, and you just can't not look at it, and it's like brighter than the sun just looking at it, and just so fun to watch most of the kids looking at me, and then there's always this guy looking over at the intense burning flame. You just can't help it. Any other questions for Sambit? All right, thank you, Sambit. I have up next that we want to see Maya's video, so if you guys could turn to that. Chem demonstrations. So thumbs up when that's good to go. Hi, Max's dad. Max, are you good?
Yeah, he says hi.
Okay, tell your cat hi too. Margaret, are you there? All right, Willie, sit down, man. You guys ready for? You guys ready at Fort Worth? Joel, I'm sorry Willie's being such a pain. Okay.
I'm used to it.
Yeah. Okay. All right. Cool. All right. So Maya's video in 3, 2, 1, go. Whoops. Got to stop the internet again. Some comments or questions for Maya? Samvit.
Let's see. It was very apparent you edited this film on a Macintosh computer, but I've never seen those like chromatic graphics in iMovie. Did you use iMovie or what?
Yeah, I used iMovie.
Okay, I gotta look for those then. Those are some cool stuff.
It's called Neon. It was one of the
Neon.
Yeah.
It's a transition or what is it?
It was just a set, like those were all transitions, and then they were on the title page. It was like when you first started up and they give you like the themes.
Oh,
it was
you
called
used the
Neon.
theme. Oh, okay,
Yeah.
okay. That's cool.
Yeah, very good. Margaret.
I think I was glad that you explained why you chose the food dye. Because at first I was like, well, of course it's not going to work. That's not actually indicator. But I didn't know that food too. I was like, well, it's not going to work. It's food dye.
Well, when I was looking it up, because I had when I first started this, I had emailed my physics teacher all the stuff that I need because he would get it, and he was like, oh, this isn't actually a thing that we have. But they actually did have it, but that's a different story. So I looked it up, and it was like, oh, indigo carmine is actually blue number 2, FDC. So I'm like, okay, I'll try and find some blue number 2. And I did, but it also had like high fructose corn syrup and read all this other stuff in it. So we tried, but yeah, it didn't work.
Max?
For the initial reaction, the one that didn't work that you were talking about, how is it that the indicator goes from like through the 3 different colors without? Would you have had to add additional things to go to each color, or is that part of the reaction that it somehow through the course of the reaction goes to like 3 different acidities or whatever it is that the indicator is?
Yeah, so what I read is that it just goes to the 3 colors on its own, and then if you shake it, it's supposed to go back to green and do it all again, depending on how hard you shake it. But I didn't actually get to try it, so.
Willie?
Why did it take so long for the second reaction to like happen? Because it was kind of like a lot of lag time, so that was interesting because it didn't do anything, and then all at once it was like totally dark blue. I thought it was really cool too. I like that.
It depended on how I think the concentration and the amount of the whatever the second one was that I can't remember right now. But it depended on how much, because actually the video I saw where I did it from, the guy used 2 different amounts of the second or third solution, and it changed the time it took for the color to go black. So I just used a little less, and it took a longer time.
Other questions for Maya? Maya, one of the things I liked about your video, well, one, I thought you did a really good job of putting music in it, and I know music's a passion of yours, but I thought it was particularly important when, I'll come back to the music in a second, but I thought you also did a good job of showing failure, which is an important part of science and an important part of research, and for many of us it's a frustrating thing, but also there's the excitement which was shown of the success that came when, all that work finally paid off. So I thought it was a great job of laying out failure after failure, documenting those, but the nice thing about a video is we don't have to suffer through all that with you, and you tighten it down to a nice video length. But again, as you built the music up to this final success, I thought that really did a really good job of bringing it all together in a really nice way. So I think that's the power of a video, and I think you really captured that well. So I want you to give it up for Maya for the great job there on that. Well edited, well done all around. Anything else for Maya before we go on? Okay. Let's go. I want to do Robin's next. So again, that one I shared with you. I guess it's on the same email, maybe at the beginning, but it's the Oobleck. So I've got it opened up as an MP4, and you guys may have it shared through Google Drive. But let me know when you're ready for Robin's piece. All right, Maya's ready, Olivia's ready, Robin's ready, Samvit's ready. Margaret's ready. Maurice and Chandler, Max. All right, everybody's ready. So we'll do Robins in 3, 2, 1, go. All right, Robin. Questions for Robin. Margaret.
I thought it was interesting that you actually made your starch from scratch from a potato, because I know a lot of people actually use cornstarch in this reaction instead. That was just like kind of a comment. But the other thing I thought was interesting, this is more of a question, was so you said that when you're applying force that, like a hard force or not a hard force, but like a force that is sort of larger in magnitude, that the water molecules are going to be escaping a particular area. My question to you is, if you were to strike that bowl really, really, really hard, would you actually force all of the water molecules out of the starch altogether and like actually get a separation? Is that possible, or is that not quite what would happen?
I'm actually not entirely sure because I really didn't apply such a huge force. Probably you'd have to test that. But I did notice that you can separate. This is sort of you can separate the suspension simply by leaving it overnight. Then the starch sort of settles and the water goes on top. And ultimately, also you can evaporate the water to just have a starch solution, a powdery starch solution. But I'm really not entirely sure whether you can, if it will really truly completely separate. I think what would happen if you applied a really strong force is that perhaps it would separate, but then it would again sort of settle down into liquid form as it did in the other sort of relatively weaker forces.
Willie?
Did you eat it? And if so, what did it taste like?
Actually, I decided not to eat it because it's supposed to be really bitter. But I think I did actually taste a tad of it. But I confess it was really quite bitter.
Oobleck. Maurice or let's go with Chandler.
This one doesn't really deal with the oobleck, but what was going on in the fire reaction?
Basically, what I did is evaporate the water from the potato starch, and what occurred was a powder was formed, and you can basically sort of set it in motion by just blowing it out of a tube, and in turn put a candle under it. So basically, what occurs is or a matchstick would also work, but that's a powder explosion. So that's basically what occurred there.
Yeah,
that's a flamethrower. That's a flamethrower, right?
Right. Yeah. So I'm glad you asked that question, Chandler, because Robin had told me a little bit through an email, so I knew what was going on. But I'm glad you asked that because that was important for everybody to understand. Any other questions for Robin or comments about his presentation? Yeah, Maurice.
Yes, I had a question about the amount of force applied. Is there like any upper limit at which the starch will actually kind of move aside of force application?
I guess I didn't really test sort of specific forces, so like in units, but I basically just did it sort of in a amateur way to some extent. So I think that it really also depends on the kind of object you use, because if you wanted to really split, then you should use something like a knife or something along those lines. But it really just a stronger force will create a solid out of it to some extent, while a weaker one will not.
Willie?
Wait, so did you just like go buy some potatoes in Jerusalem and then like fire a flamethrower in the streets of Jerusalem? Like any blowback from that, or anyone get upset?
Actually, I did take some safety precautions, so like, luckily not.
Thanks for that question, Willie. Because I think it's important to understand Robin was on vacation basically in another country and was able to pull this video off. And Robin, you clearly did all editing and everything else while there, right? Wow. So any other comments or questions for Robin? Sambit, thanks.
I just wanted to compliment Robin on the presentation of his first part. The transition to the explanation was a bit abrupt, but I liked how you gave the topic a comical spin, using some Kevin McLeod. That was interesting.
Thanks, Sambit.
Yeah, Robin, I want to say a couple of things about your piece. One, you started off with nice music that then changed later, which I thought was good. I loved the potato that rolled across the screen because you set something up that was basically like a movie there, and then you went into peeling it in a very unique and interesting way. So you got the reader really captivated at the beginning and wondering what was going to happen next, and then your dialogue helped explain things. You used slow motion at one point. Brilliant, right? Because you're talking about a fluid where you have to see what's going on, and your audience needs to be brought there. And you chose slow motion there, which was excellent because of the nature of your fluid. The pounding versus the touching, you brought that to life in a really, really cool way. So, and then you switched to a chant. So the music changed very much when you went to this dark streets and you were blowing the powder through the. So again, that was again a brilliant choice as a filmmaker there to do that. So I thought you just really nailed it in terms of everything that you did. So great job. Let's give it up for Robin on that one from Jerusalem, Israel. Nice. All right, very good. I think we can pull this off. We're going to try for Chandler's hydrogen peroxide demo. So if you guys let me know if you've got that loaded up. 1, 2, 3. Not? Okay, that's okay. Chandler's was sent earlier than this group of videos, so it would be the email from me before I sent the whole plug, and I probably should have sent it with the original, but all right, now you're good, Margaret. Samvit, are you good?
How do I rotate the video?
I have to turn my head, so maybe what I'll do is I'll turn my screen. I'll turn my computer. Any other suggestions?
Yeah, my bad on that one. No wrong.
Yeah. You're bad.
All right. It looks like we are set, and we are going to start Chandler's video in 3, 2, 1, go.
Clear substance. So if you guys enjoyed this reaction of hydrogen peroxide decomposing into water and oxygen.
Mine started a little late, so sorry for the late entry on the clap scene there. All right, questions for Chandler or comments? Thanks, Joel.
What causes the color change? Like, where's the color coming from in that?
I think it came from the potassium ion being placed in the solution, but I wasn't too certain there, because I know water is colorless and oxygen as well. So I think it was from the potassium ion.
Yeah, I don't know, because potassium is supposed to be colorless, so I wonder if, yeah, the iodide somehow, and I don't know, though, either, for sure. Other questions for Chandler? Yeah, some bit.
From prior experience, my understanding is iodine has certain color properties. So that might have been the main contributor to the coloring of the reaction.
Yeah, I suspect so too. He didn't show it in his reactions, but I'm wondering if there's a little bit of side contamination producing some iodine. Yeah, good hypothesis. Other questions or comments on that one? Chandler, you mentioned the IO minus ion. Do you know the name of that? I feel like you named it in the video, but
Yeah, hypohydrite ion, I believe. I don't know if I'm pronouncing it correctly.
Okay, yeah, I think I'd say hypoiodite, but because it's it's sort of like the hypochlorite ion. It's just there's an iodide instead of a chloride. Yeah. Okay, and so that's Margaret. Go ahead.
Okay, I know this is probably not in the reaction, but triiodide appears yellow in low concentrations in solution. So I think iodine has the capacity of having a yellow coloration. It might not be in the triiodide form in this reaction, but that may be a potential source.
Yeah. Yeah, every iodide I know, like silver iodide has a yellowish color. Lead iodide is very yellow, very bright yellow. So I would think it's somehow the iodide is giving it that color as well. Yeah. Chandler, does hydrogen peroxide decompose on its own?
Yes, and it takes like a longer time, especially at low percentages, like the 3% that you buy like at the drugstore. But in ones you can get in like chemical labs, 30%, they are even contained in like in these accordion bottles that can expand due to the oxygen that's produced when it decomposes.
Yeah, cool. Yeah, we keep our 30% in our refrigerator. Again, that helps lower the decomposition rate because it is slowly going to decompose over time, and that just slows the kinetics a little bit. Yeah, and 30% hydrogen peroxide is pretty dangerous stuff. You have to be pretty careful with it. Very good here. Did you think through whether your hydrogen peroxide's undergoing oxidation reduction, both, how that works? Have you thought that through?
No, I haven't.
All right. If you took a little time, you could figure it out because the peroxide's in a weird state. It's in the the -1 state for the oxygen. So if you actually look at your reaction, maybe let's give your classmates and you a little time to think that through. If you guys look at the reaction H2O2, the oxygen starts in the -1 state, and then your products are water and oxygen. So why don't you guys try to think through a little bit what gets, what's the oxidation, what's the reduction there, and you guys will figure it out in just a little bit. I know Willie's got it. Let's wait on him a little bit more.
Actually, I'm sorry, it's 2:15, and I actually have a doctor's appointment, so I gotta run.
All right, man. Take care. Don't throw any paper at your doctor. Joel, translate for me. Sambit, you want to tell us what's going on?
With regards to oxidation reduction, without looking at the periodic table, my understanding is oxygen is getting reduced from -1 to -2, and iodine is being oxidized from 0 to +1.
So I agree with the first part of what you're saying, but not the second part. So it's a bit of a trick question because the iodide never changes oxidation state. Well, it may change, but then it changes back. So in other words, it's a net. So the bottom line is the net reaction is only hydrogen peroxide changing into water and oxygen. So somewhere within the net, you should be able to find. So I got part of what you said.
Okay, I was looking at the first line only. My bad. Okay.
Yeah. No, you're right about the first line. So you need to look at the net. So you're totally right about the first line. Let's go to the net. Anybody? You guys want to chew on that a little bit till next class? We'll start off on Chandler. Tell us what it is.
So like as Sambit said, the peroxide, since it's H2O only, it's reduced, so the oxygen is being oxidized, I guess. So oxygen.
Good. Yeah, so half of it goes up and half of it goes down in oxidation state. Good. All right, I will see you guys on Thursday for our last class. Get pumped. And the only person I won't see is, you two, Chandler and Maurice. I'm going to miss you guys. This is probably goodbye for you guys then, at least in person. So maybe we'll correspond by email. I really liked having you guys in class. Thanks for everything.
And thank you very much. We definitely enjoyed this class. So.
Awesome.
It was fun meeting you guys.
All right, good. Sorry we didn't leave more time for that. What?
I liked Margaret's jacket. It was art of problem solving.
Oh, cool. Yeah. Robin, take care.
Thank you.
You'll still be in Israel next or Thursday?
Yep.
All right. Have a good trip.
Thank you.
Great job on your video. Good job, Sunbit.
Thank you.
Bye, Mr. Walker.
Take care, guys.